Hey, 8th grade students, you guys have a test this week, so let us review for that. So the first question says the area of a square is blah, blah, blah. Square units determine the length of each side of the square by factoring the area expression completely. So the one thing we do know about squares is that all the side lengths are exactly the same. So this looks like a perfect square trinomial. And I say that because the first and the last terms are perfect squares. So let's try finding the square root of those two numbers. So 16a squared, the square root of that is 4a. Square root of 9 is 3. So I need two numbers that multiply to give me positive 9, but add to give me negative 24. So I'm going to try this right here. Well, let's see if it's right. Let's say 4a minus 3 times 4a minus 3. We're going to FOIL it. So 4a times 4a is 16a squared. 4a times negative 3 is minus 12a. Negative 3 times 4a is negative 12a. And then negative 3 times negative 3 is positive 9. So sure enough, it looks like that is, that's the answer. Yep. All right, so the question is, what is the length of each side? The length of each side is 4a minus 3, which makes sense because squares have all the sides the same length, right? All right, let's look at the next question. Well, all right, now this area of a rectangle, so rectangle side lengths do not have to be the same, right? So this is, I noticed these two terms are both perfect squares as well. And actually it's the difference of squares. So we've had problems where we had to factor difference of squares. So the square root of 9a squared is 3a. The square root of 25b squared is 5b. And since it's the difference of two squares, that means one gets a plus and one gets a minus. So if I FOIL this, I would get this expression right here. And that answer looks good because, like I said, rectangles side lengths do not have to match exactly. So we would say that side one or side, it doesn't matter. One of the sides dimensions is 3a plus 5b, and the other one is 3a minus 5b. And I think we're good. I like it. I like it. All right, number 2. So it says we're going to find the greatest common factor of these two terms. So the biggest number I can divide 12 and 16 by would be what? 4. The biggest group of a's they both have in common is 3 a's, or a to the third, and the biggest group of b's is b squared. Now, I don't have to factor this because it only tells me to find the greatest common factor, but just to be sure, I want to see after I factor it, I want to make sure the two numbers left don't have any more common factors. So 12 divided by 4 is 3. A to the fourth, take out 3 a's, that leaves me 1a. And then b to the third divided by b squared is b, plus 16 divided by 4 is 4. I took out all of the a's and all of the b's. So that would be my answer factored, which gives me confidence because these two terms do not have common factors. So I know that 4a cubed b squared is the actual answer. This does say factor completely, so that extra part on number 3 is required. So I noticed that these are all divisible by 5. I always want my leading coefficient to have a positive coefficient, which means I'm going to factor out a negative 5. So if I divide negative 5 by 5, I get 1, and 1 times x squared is x squared, minus 2x minus 3. All right, now I would double check this. I'm sorry, it's positive 3, isn't it? You guys, hopefully you guys are doing these with me or ahead of me even. And if you find my mistakes, you'll just yell out the computer screen. Let me know. Now I do want to double check. Is there any way I could continue to factor this? Are there two numbers that give me a product of +3 and a sum of -2? Well, the only two factors of 3 are 1 and 3. And they either both have to be positive, which is not -2, or they both have to be negative, which is again not -2. So that means I'm done. There's nothing else I could do with that right now. All right, this one once again says factor completely. So I am thinking of a number I can divide 12, 6, and 9 by, and I know that number is 3. What's my biggest group of x's? Just looks like x to the first and y to the first. So now I'm going to factor that. I get 4x squared plus 2xy minus 3y squared. Is that right? Did you get that? I bet you did. All right, let's look at this one. It says an expression is shown below. The first question is what are the x-intercepts? So the x-intercepts is what x is when y is equal to 0. So the first thing I notice is this is a quadratic equation, which means I either going to get a parabola facing up or a frowny parabola facing down. And since my leading coefficient is a positive, I do know it's a parabola that looks like this. It's facing up because this is a positive number in the front. So now I'm going to take this and I'm going to set it equal to 0 so that I can find the x-intercepts. It says +0, but I don't even need that, do I? All right, so now I'm going to factor this. Well, if we just think about this not being there, then the first thing I notice is that I can factor out an x from x squared and 6x. So x squared divided by x is x, and 6x divided by x is 6. And that's as much as I can do with that. But now I take each section and set both of them equal to 0. Because either if this is equal to 0, the whole expression is, or if what's in the parentheses equals 0, my whole expression would be equal to 0. So that means we have two answers. It looks like one of our answers is 0. X is 0 and y is 0. The other answer would be that x is equal to -6 when y is equal to 0. So let's write these up here. So our x-intercepts, we have two of them. And for all parabolas, you either have 1, 2, or 0, right? So our x-intercepts are 0, 0, and -6, 0, all right? And now I think our next step is we have to find the vertex. So I'm going to go ahead and write this up here. I'm going to get rid of all this stuff, I think. Ooh-wee, I did not mean to do that. Can I back up? Oh, no. Oh, no. Do y'all remember our answers? Our x-intercepts were 0, 0 and -6, 0. Okay. I actually remembered. Y'all are going to be my age one day. You'll understand. And now we want to know what the vertex is. So let's look at the next problem. Is the vertex of the graph of f of x going to be a maximum, which means the highest point, or a minimum, which is the lowest point? Well, when you have a smiling parabola, these two lines will go up forever, right? So there's no maximum, but there is a minimum. So with happy parabolas, you would have a minimum or a lowest point, which is going to be your vertex. So now it wants to know what is the vertex? What are the coordinates? So do you remember that little formula? The formula is -b over 2a. That's the x value. And then to find the y value, you plug in that x value into your equation. So our leading coefficient is a. So a is 1. B is always multiplied by x to the first power. And we don't need c right now, but we do know in this situation it is 0. All right, so our b is 6, so we're going to do the opposite of 6 divided by 2 times a, and 2 times 1 is 2. So -6 divided by 2 is -3. So our x value of our vertex is -3. And now to find the y value, I'm going to plug in -3 in for x. So we have -3 squared plus 6 times -3 plus 0. So we have 9 minus 18. So our y value is -9. So our vertex is -3, -9. It tells me to graph it. So here we go. We're going to graph these 3 parts, or these 3 coordinates. I'm going to start with the vertex. I'm going to go left 3, down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's our vertex way on the bottom. One of our x-intercepts is 0, 0, 0, and the other one is -1, 2, 3, 4, 5, 6. So there is going to be our parabola. There we go. Oh my goodness. So close to perfection, so close. Now it doesn't ask for our line of symmetry, but y'all remember finding the line of symmetry, it would be what is that equation? X equals -3 would be the equation. So always x equals the x value of the vertex. All right, how we doing? Are y'all working with me, ahead of me, checking your answers? I love it, I love it. All right, so it says rewrite the expression after factoring out the greatest common factor of all 4 terms. So it even gives me an example. For example, have your greatest common factor outside here and all 4 terms left inside. So what can I divide 3 and 12 and 18 and 72 by? I can divide them all by 3. Let me just write this right here. All right, well, how many x's can I pull out of all 4 terms? Well, only 1 x in all 4 terms, and the same thing with the y's, only 1 y. So I'm going to factor out 3xy from each term. So 3 divided by 3 is 1. X to the 4th divided by x to the 1st is x to the 3rd. And then I pulled out the y. And then I have 4x squared minus 6x, right, minus 24. All right, so that is the answer to part A. This is the answer to part A. Part B, on the other hand, wants us to continue going forward so that the expression is completely factored. So do you remember how to factor term or expressions that have 4 terms? Well, we do it by grouping, right? So let's go ahead and do our parentheses in here. All right, so let's look at these first 2 terms. What could we divide out of these 2 numbers? We could divide x squared out of both of them. So x to the 3rd divided by x squared is x plus 4, right? And then what about these 2 terms? I can divide out a -4. And so I have -6 divided by -4. Oh, what am I saying? Not 4, silly Willy. It's a 6. It's a 6. All right, so then we have negative divided by negative is positive x, and negative divided by negative is positive 4. So now, do you remember what happens? These match perfectly. So one of our factors is x plus 4. The other factor is when we put these together. So the other factor is x squared minus 6. And then all of that is times our greatest common factor, which is part of our final answer. And that is part B. How'd you guys do? Now, if I wanted to triple check my answer, I could FOIL these 2 binomials and then multiply the final answer by 3xy every single term. And guess what I would get? I would get what I started with. I hope this is helping you guys. All right, number 7, it says factor by grouping. So we just kind of did that. So when we factor by grouping, we're going to circle. Well, you know what? I'm going to rearrange these because I noticed that these 2 terms have things in common and the first and last term do. So I'm going to rewrite it a little bit. You don't have to do this very often. But if I tried to find a common factor of these 2 terms, there isn't any, right? So sometimes you might have to rewrite these in order. All right, so now I bet I can find common factors, don't you? So I can divide both of these by xy. Xy divided by xy is 1 plus 2xy divided by xy is 2, which is just 3. And then I can pull out of both of these what? A b, that's it. So I end up with a plus 2y. I wonder if I wrote this problem correctly. Because these don't match exactly, but I did group them and I did find common factors, but anyway, that's the final answer I got. I can't go any further because these don't match. These don't match exactly. All right, let's look at number 8. We're going to factor completely. So let's group these. So what can I divide out of both of these terms? I could pull out a 2x squared, and I would end up with x plus 5. And then here I could pull out a positive 4, and 4 divided by 4 is x, or 4x divided by 4. And then now this time we do have matching parentheses, don't we? So what would my final answer be? My final answer is 2x squared plus 4 times x plus 5. So that one worked out. The first one didn't. Okay. Number 9, it says factor by the AC method. So the first thing I notice is that I can't pull out of anything out of all 3 terms. I don't have any common factors. So I am going to factor by the AC method, which means multiply A times C, which is 12. So I want 2 numbers that multiply, give me 12, and add to give me 13. So that would be 12 and 1, right? So I'm going to rewrite the first term and the last term, and then my middle term is going to be 12x and 1x. And doesn't 12x plus 1x equal 13x? Yep. And then I bring down that last term. So now I am going to, since I have 4 terms, I'm going to factor by grouping again. What could I pull out of this? Both of these, I could divide out a 3x. 3x squared divided by 3x is x. 12x divided by 3x is 4. And then, don't these already match? But I still have to show that I'm factoring out a 1. So my final answer is x plus 4, because those match exactly. And then I'm putting the other 2 terms together. And that is my final answer. And it wouldn't matter if I, this one was second and this one I wrote first. It would not matter. Doesn't matter. All right, let me clear this screen. Number 10, which polynomial is a perfect square trinomial? So that was similar to the very first problem we did, right? All right, so basically, do you remember the characteristics of a perfect square trinomial? Are the first and last terms perfect squares? They are, but once we think of the square roots of these, we have to be able to get to that second number. So this would be 2 and 2 and 3. Would 2 and 3 ever add up to give us 6? Nope. All right, what about the square root of 25b squared and 16? Let's try this. Let's see if we can get negative 40 out of these 2 numbers. All right, so we're going to do minuses. All right, so we have 25b squared, and this would be negative 20b minus 20b. Negative 20b minus 20b, is that negative 40? Yep. Ding, 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 ding. Winner, winner, chicken dinner. We can try the other ones. Let's try 6x and 3. 6x and 3. First of all, we know that this last term would have to be a positive, because if we multiply 2 negatives or 2 positives, we get a positive. So these are out. Just because of that sign right there is not correct. It wouldn't be a negative number. Okay? because you can't, there is no square root of a negative number. All right, number 12, find the zeros of, so basically this is the same thing as when we found the x-intercepts. So the zeros of means you just set this equation equal to 0. So we're looking for two numbers that multiply to give us -3 and add to give us -2. So that's going to be -3 and +1, right? So square root of x squared is x. We're going to use the factors -3 and +1. So -3 plus 1. Now, if we FOIL this, we would get x squared plus 1 minus 3x, which is -2x, and then -3 times +1 is -3. So now that we're setting it equal to 0, we have to take both sets of parentheses, set them to 0, and then solve for x. So we would add 3 to both sides. So x is equal to +3 and -1. So those are the zeros of that expression. Clear the board. Oh, 11, we did, excuse me. We did 12 first, but it doesn't matter. All right, now this one is the difference of squares. So difference, first of all, means subtraction. So without even looking at numbers, I can get rid of this and this. And then it says square. So obviously the two terms have to be perfect squares. Well, I only see one perfect square. It's not 14, but it is 49. So the difference of squares, one would get a plus, one would get a plus and one would get a minus. So that would be the answer. Foiled, or not foiled, unfoiled. I don't know what that unfoiled term technically would be. I'm sure there's a wonderful term. I just don't know what it is. Oh, look at this question. This is great. Which of these is an odd degree polynomial? And which of these is an even degree polynomial? So that's confusing. But basically what it wants to know is which one of these, what is going to make this parabola? It's a quadratic, isn't it? Which means that first number has to have x squared. Whatever the rest of it is, it doesn't matter. But isn't a 2 an even degree polynomial? So the blue line, or f of x, has an even, it's an even degree polynomial. And then if that first number is a cubed, whatever, I'm just making this up, but I do know in order to have a cubed, the leading or the degree of the polynomial, the biggest exponent has to be a 3, and it's always going to make this squiggly line right there. It's either going to start and end in a positive manner, or it's going to start and end in a negative manner. Oh, and that's the question. Are the leading coefficients positive or negative? So what helps us determine that? So we know that the quadratic is blue. Do we know if this is positive or negative? Well, it's going to be positive, because if it's positive, the leading coefficient is positive, we have a happy parabola. If it's negative, we have a sad parabola. Same thing with our cubic graph. If it starts going up and to the right and it ends going up and to the right, it's positive. If it begins going down and to the right and ends going down to the right, it's negative. So since this is going up and to the right, it means that the leading coefficient is also positive. So both of these have positive leading coefficients. So number 14 says, can this expression be simplified? So first of all, I notice that they're both perfect squares. So if I find the square root, I get this. So the question is, can it be simplified? Which means if it's the difference of two squares, we know that one of these gets a plus and one gets a minus. But that middle term would be a subtraction, so that's not going to work. The other thing we got to keep in mind is if they're both positive, there's always going to be a middle coefficient, because we would have two numbers in the middle that would add to, they would be like terms and we'd add them. Or the opposite is true. If they were both negative numbers, negative signs, we would have a middle term as well. So the answer is no, this cannot be simplified. So if it's not able to be simplified or factored, your choice on in Canvas would be it's prime. So no, the answer is no, because it's prime. All right, now 15, even though we know exactly what quadratic equations look like, in order to figure out exactly what cubic equations look like, we would have to use some calculations, and we're not that far yet. You'll be there one day, but not yet. But we can get an idea of approximately what this will look like when it's graphed. So the reason we can do that is because we know what the y-intercept will be, and we can figure out the x-intercepts, okay? So just like finding the x-intercept earlier, that just means that we are setting this equation equal to 0, and we're factoring it. So let's do that first, figure out what the x-intercepts are. Remember, if this is a 3, that means in the front, that means we're going to have 3 solutions. So we're going to actually have 3 x-intercepts. So we can factor by graphing because there are 4 terms here. So what do these two terms have in common? Well, x squared. And then if we factor out x squared, we get x minus 3. And then here we have this, we can pull out a negative 4, and we'd have x minus 3. Okay, so that means our two binomials would be x squared minus 4 times x minus 3. Well, then this, do you notice, is the difference of two squares. So we find the square root of x squared, square root of 4. One gets a plus and one gets a minus. And then x minus 3 is part of our answer. So we have 3 different sets of parentheses to set equal to 0. So x plus 2 equals 0, x minus 2 equals 0, and x minus 3 is equal to 0. So our x-intercepts are negative 2, 0, positive 2, 0, and positive 3, 0. Because if we solve for x, we would add 3, so on and so forth, right? Are y'all with me? All right, the other thing I told you we could find is the y-intercept. And how do we find the y-intercept? That's when we set x equal to 0. Well, it's easy to do that. It's so quick to do that when all of the terms is multiplied by x. So 0 cubed is 0, 0 cubed is 0, 0 minus negative, or 0 times negative 3 is 0. So this is 0, this is 0, this is 0. So when x is 0, y is 12. All right, so let's graph these 4 points. So 0, 12 comes way up here. So there's our y-intercept. Our x-intercepts are negative 2, 0, positive 2, 0, and 3, 0. All right, we know that our leading coefficient is positive, so it's going to start by going up and to the right. So basically our, what did I just do? So we're going to start by going up and to the right. And our line, it's so hard for me to draw on this thing. Our line would go, oh my goodness, you guys, it would go way up here. It's going to make a curve and it's going to pass the x-axis somewhere here. And then it's going to come down. It would go through our x-axis here and come back up and pass again. Oh my goodness, is that the worst thing you've ever seen? It's about the worst thing I've ever seen. But if I pull up the actual graph, yeah, pretty bad. Pretty bad, but we can get an idea because it passed like here. I know there's writing on the screen, but you see that we got our y-intercept in the right spot. We got our x-intercepts in the right spot. We know how the graph begins and ends. So my drawing's not perfect, but when are they? They never are. They never are, but that's okay. All right, you guys, that's it. So I hope that helped. I know you guys are going to do great on your test. So that's all I ask of you. Just do your best. Everybody have a great day. I will see you guys later.